So here we're trying to figure out if these two triangles are congruent to each other. Well, currently we have two different forms or two different theorems or postulates that'll allow us to figure that out. And one of them is side angle side. I always forget which ones are postulates, but the side angle side postulate or the side postulate. Now, the first thing, and now if you're one of my students, you can probably predict this, that I'm going to recommend we do is try to figure out what these look like. Now, I'm not going to bore you with me writing it out. So here is what they look like when you plot all of the points and draw the triangles. Now, looking at these two triangles, sometimes looking at them, if you have a really accurate drawing, will be enough. If they're clearly like way off, you'll at least know where to disprove that the two triangles are congruent or are not congruent. In this case, they're pretty close, although it's looking like they might not be. But looking at the information I have, well, they didn't give me any information about lengths or angles. However, I do know how to find the measure of the sides if I have the coordinates using the distance formula or just right triangles. And so here I have the side angle side postulate. I'm not going to be able to use that. I'm going to be looking to try to prove that all the sides are congruent or the corresponding sides are congruent. Well, to do that, what we're going to do is just draw out and just count up these right triangles here and use the Pythagorean theorem to do this. And so here I'm going to have 1, 2, 3, this is 4 units tall. And then counting over from here to here, I'm going from 3 to 8. Well, that's 8 minus 3, that's 5. And so to find d, the distance right here, I know that d squared is just equal to 4 squared plus 5 squared, the Pythagorean theorem. A squared plus b squared equals c squared. And so I get that d here is just the square root of 41. I'm going to do that for the second drawing here. So I travel out, again, making this right triangle here. That's 1 unit tall right here. And then I traveled from 3 to 12. That's a total of 9 units. And if we want to count from one number to another, we can just subtract. And I'm just going to kind of do this one in my head, but 9 squared is 81. Plus another 1 squared, well, that's just 1, so that's 82, and then we take the square root of it. So this leg right here is the square root of 82. So obviously those wouldn't be corresponding sides, okay? I went ahead and off camera, I did all of the other sides, and we can see here that none of the sides actually match up. If I look here, I've got a side that is the square root of 58. There is no side that's the square root of 58 over there. So automatically I know it can't be side, side, side because I would need 3 pairs of sides. And if this one doesn't match up with anyone, then I'm done. But by drawing it out and actually finding these measurements, we've proven that these two triangles are not congruent. And in fact, we didn't just prove that ABC isn't congruent to DEF. We proved that no combination of these is.